to obtain 31p NMR spectra from the kidneys of living rats. Since 1980, has been at the San Francisco VA Medical Center, UCSF. He is currently director of the Center of Imaging for the Neurodegenerative Disease, a 10,000 square foot building with one research MRI, and he is also professor of radiology, medicine, psychiatry, and neurology. He has published over 500 papers. His grants include studies of Alzheimer's disease, vascular dementia, frontotemporal dementia, Gulf War illness, post-traumatic stress disorder, HIV, and other neurodegenerative diseases. He is the principal investigator of the NIA, who funded $60 million for the Alzheimer's disease neuroimaging initiative. In 2007, he was awarded the Middleton Award for outstanding research in the VA. In 2010, he was awarded the Gold Medal of Paul Sabatier University in Toulouse and the Gold Medal of the City of Toulouse in France. In 2011, he accepted the Ronald and Nancy Reagan Research Award of the Alzheimer's Association on behalf of the ADNI project. He is married with 2 grown children. He lives in Mill Valley, California, and he is also a professional jazz pianist and has recorded 2 CDs called Mike Weiner Trio and Mike Weiner Live in Havana. Let's welcome Dr. Weiner.
So I've been studying Alzheimer's disease for the past 25 years. And my mom, who's, God bless her, is 99 years old, she has quite severe Alzheimer's. She still knows who I am, but she has essentially no memory, and she's kind of very slowly progressing, but otherwise very healthy, living in a Alzheimer's care facility. So I can really relate to a lot of what you guys are doing. So basically, I want to talk to you about how I see us getting to having ultimately effective treatments and a prevention. Gil Rabinovici did speak about this a little bit earlier, but I'm going to give you what my approach is and how I'm kind of working on it. And at the end of this talk, I'm going to tell you how you could help. The first is really the big picture, which I'll just repeat, because Alzheimer's disease is characterized by amyloid plaques, which are outside of cells, and tau tangles, which are inside of cells, the loss of nerve cells, memory problems, cognitive decline, leading to dementia. Now, what's really remarkable about Alzheimer's disease, it's a really common disease, and it's essentially probably caused by 2 proteins, amyloid and tau. That's the thing to remember, just amyloid and tau. And that gives us targets. In cancer, in diabetes, in schizophrenia, in fact, there's no other common disease that you can mention in which you can say it's caused by 1 or 2 proteins. So that's the good news. At least we have good targets, and drugs are being developed to be aimed at those targets. Previously, up until just a few years ago, we defined Alzheimer's disease purely by the symptoms. Just like back in the old days, heart attacks were diagnosed by chest pain. But then, through technology, doctors learned that you could diagnose heart attacks by using EKGs, which are electrical signals, and by certain types of blood tests. So we call those biomarkers, tests that give you information about the biology of the disease. What's happened in all of neurology is that increasingly biomarkers are being used to help us identify the diseases. And nowhere has that happened so remarkably as in Alzheimer's disease, especially because of advances in MRI scanning and PET scanning and the ability to measure amyloid and tau in the fluid which we get from a lumbar puncture. So nowadays, of course, the clinical signs and symptoms of a disorder are important, whether a person has memory problems, emotional problems, depression, and how progressive that is clinically. That's, of course, the bottom line for the patient and the family. But the ability now to make a specific diagnosis using these biomarkers has essentially revolutionized our field and allowed us to be much more specific about what the cause is in an individual patient and ultimately to tailor the treatment. So I've been particularly interested in biomarkers because I got involved with the development of MRI back in the early 1980s, started using MRI to study Alzheimer's disease in the late 1980s, and then more recently I got interested in seeing how we could use biomarkers to improve clinical trials for Alzheimer's disease. So basically I'm going to talk about three things. First, I'm going to talk about the Alzheimer's Disease Neuroimaging Initiative, otherwise known as ADNI, which is a big project standardizing biomarkers for clinical trials, which shares the data. Then I'm going to talk about how we're using the ADNI project specifically to study traumatic brain injury and post-traumatic stress disorder in veterans. And finally, I'm going to talk to you about a new project which we've started in the Bay Area called the Brain Health Registry. And that's an opportunity for you folks to be involved and help spread the word and get people signing up, including yourselves, for this website so we can speed up clinical trials. So first I'm going to tell you about the Alzheimer's Disease Neuroimaging Initiative, or ADNI. We've received $140 million of funding from the NIH and the private sector. The goal of ADNI is to validate biomarkers for clinical trials. It's a huge project which involves many dozens or hundreds of investigators. You can see a map here of the United States. There are 60 sites all across the United States, including San Francisco, Stanford, Palo Alto, Los Angeles, San Diego, New York, Boston, et cetera, et cetera, et cetera. We've enrolled over 1,500 subjects into the study. It's been going for a little more than 10 years now. We've got a large number of normal, healthy subjects with a mean age of about 73. In fact, I am a subject in this study myself. I have all the procedures. We've enrolled 150 subjects with subjective memory complaints, 850 patients with mild cognitive impairment, and 350 patients who have dementia due to Alzheimer's disease, and they're all followed longitudinally every year with MRI scans and PET scans and lumbar puncture and clinical. So it's a huge amount of data that we get on all these subjects. And a remarkable aspect of this project is that we share all of the data that's acquired from this project on the internet with any scientist in the world who wants it. And there's no embargo of the data. In other words, if your mother was a subject in the Alzheimer's Disease Neuroimaging Initiative and she had an appointment tomorrow and had an MRI scan, within a week that MRI scan would be available, of course without her name on it, it would be available on the internet so that other scientists could use it in their projects. And that's resulted in more than 650 publications from this project. So the data is used by the pharmaceutical industry to help design clinical trials. And we do all kinds of imaging. I don't have the time to get into it, but I just want to share with you some data that we've recently come from Dr. Jagus, who Gil mentioned earlier, who analyzed this data, concerning what we call here the florbetapir status, which is a measurement of how much amyloid is in people's brains. So what this basically shows you is that in the normal, completely normal, healthy people who are completely healthy, mean age 73, 27% of those normal, healthy, average age 73-year-old people, 27% of them have amyloid in their brain at the level of a patient with Alzheimer's disease. There's almost a third of normal, healthy 70-year-olds. If you look at patients with early mild cognitive impairment, 45% of them have a lot of amyloid in their brain. If you look at traditional late mild cognitive impairment, 67% of them essentially have early Alzheimer's disease because they have a lot of amyloid in their brain. But here's another interesting fact. If you look at the patients who are diagnosed at academic medical centers with dementia due to Alzheimer's disease, only 85% of them have a lot of amyloid in their brain. 15% of those people diagnosed with Alzheimer's disease do not seem to have Alzheimer's disease. They do not have a brain filled with amyloid. So that's a very, very interesting finding. What it means is we cannot rely on clinical diagnoses alone. We need to use biomarkers to establish a diagnosis. And this is being used now more and more in clinical trials and will ultimately come into clinical practice. If you look at whether or not you have the ApoE4 gene, which is a a gene which exists in about 20% of the population normally and in about 60% of patients with Alzheimer's disease. It's a risk factor for Alzheimer's disease. You see that if you're a normal, healthy person, mean age 73, oops, I went the wrong way here. Let's see if I can take it back. If you're a normal person in your 70s and you have the ApoE4 gene, 46% have amyloid at Alzheimer's level. Whereas if you don't have the ApoE4 gene, it's only 21%. If you look at people with dementia due to Alzheimer's disease, down here at the bottom, if you have the ApoE4 gene, 98% have a lot of amyloid in their brain. But if you're diagnosed with dementia due to Alzheimer's disease and you don't have the gene, only 58%. In other words, 58% of those people really do have Alzheimer's disease. The other 42% don't really have Alzheimer's disease. And we have data now suggesting that if you have amyloid in your brain, you're going to progress more rapidly, which I think I'll show here. For example, in the patients with mild cognitive impairment, within 2 to 3 years, 25% of those patients who are amyloid positive converted, but only 2% of the MCI patients who are amyloid negative converted. In other words, having high levels of amyloid in your brain is a very important risk factor that predicts your progression to decline and dementia. And if you don't have amyloid in your brain, you're going to progress much more slowly. Now, we've taken the methods that we've used, that we've developed in the Alzheimer's Disease Neuroimaging Initiative, which is funded by the NIH, and we are able to get a lot of funding from the Department of Defense to study the effects of traumatic brain injury and PTSD on the development of Alzheimer's disease. So this project's only been going for a couple of years. I don't have any actual or very little data to show you, but I'll just describe the study to you. Because as Chris mentioned previously, having a traumatic brain injury seems to be a risk factor for the development of dementia. And most people think that having a traumatic brain injury increases your risk factor for the development of Alzheimer's disease. But in fact, it's not been conclusively shown that traumatic brain injury is really a risk factor for the development of Alzheimer's disease, confirmed pathologically or with biomarkers. And that was the point of this study. This study is being conducted on veterans who served in the Vietnam War, which is when I served in the Air Force, who have either traumatic brain injury, post-traumatic stress disorder, or completely normal people. So the major hypothesis is that veterans with combat-associated traumatic brain injury or PTSD have an increased risk for Alzheimer's compared to their veteran controls, measured with amyloid scans or rates of atrophy of the brain or measures by changes in cognitive function. So basically, we've been able to get access. This is a completely unprecedented study. The VA gave us access to the personal records of every single veteran who served in Vietnam who had a diagnosis of traumatic brain injury or post-traumatic stress disorder, and they gave us their contact information. So we can reach out to these people by brochures, by phone calls, interview them, and see whether they're interested in serving in the study, and then we refer them to an ADNI site that is near where they live. So we're enrolling people with and without mild cognitive impairment who have had either traumatic brain injury or PTSD, or they have a skin disorder, so they're service-connected, but they don't have either, and they serve as the controls to the people with TBI and PTSD. It hasn't been easy to do this study for a number of reasons. We mailed out almost 10,000 brochures. We called, so far, over 6,000 veterans. We have a group of people who are in a phone bank. We have pre-screened 2,000 of those veterans, mailed out 500 consent forms, got back 319 consent forms, and then processed those 319 for more intense interviews, and ultimately, so far, we've enrolled 58 subjects. Our goal is to enroll 400 subjects. So we're having, well, you can see there's difficulty in enrolling in this study. It's a very, very intense study. It involves MRI scans and PET scans and lumbar punctures and extensive battery of tests. So you can imagine that not everybody wants to do it, and not everybody meets our criteria. You can see here that the biggest problem we have right at the beginning is that people say to us they're not interested. They don't want to do it, and we understand that. So we pursue the people who are interested. Then the next problem is, as you can see, a large number of them have this blue. They are MRI unsafe. There's a lot of shrapnel in the body of a lot of guys who serve in combat. So they cannot go into an MRI because they have metal, which would be attracted by the magnet. And there are other reasons why they're excluded. For example, drug and alcohol use is a common problem in people with traumatic brain injury. It's a common problem in PTSD. And people who are abusing drugs and alcohol, we can't have in our study because that kind of essentially confounds our results. So, and then there are people who don't even show up at the study. But here's what we found so far. Here we're looking at the levels of amyloid in the brain, and over there on the left, these are the levels of amyloid in the brain in the completely normal, healthy subjects. And here, this line here is what we call the upper limit of normal. So these are the normal subjects here who have high levels of amyloid similar to Alzheimer's disease. And then here, these are the normal controls in the veteran study, the PTSD subjects in the veteran study, the traumatic brain injury subjects in the veteran study, and those with both PTSD and traumatic brain injury. So you can see that for the most part, the people in the veteran study, their amyloid levels are not any higher than what we're seeing in the regular ADNI controls, with two exceptions. You see these two cases that are marked A and B. So Dr. Jagus noticed these two cases and took a look at them. And here's the first case. And what's very, very interesting, so this is an amyloid scan on a patient who served in Vietnam who had a traumatic brain injury. And what Dr. Jagus has noticed is that if you look here on this side of the brain, that the pattern of amyloid is asymmetrical. There's a lot more amyloid on this side than there is on this side. And Dr. Jagus has looked at hundreds and hundreds of these scans from the bigger ADNI study and had never seen such striking asymmetry. So now we're wondered which side of the head this person might have had their TBI on and whether that may have influenced the development of amyloid. And similarly, the next scan also, there's considerable asymmetry with more amyloid there, as you can see on the side I'm pointing to. So this is an interesting point, but we're going to have to do a lot more subjects to find out what's going on. Now, the next thing I want to tell you is just to follow up on what both the previous speakers talked about, is the importance of tau. Because there's been a lot of interest in amyloid and measuring amyloid with PET scanning, but now there's new PET tracers to measure tau. And here we have, here's an example of a healthy control on the left who doesn't have any tau, and a patient with Alzheimer's disease who you can see has got all this red stuff on the right side of the screen, and that probably is tau. And here's another example of a healthy control in a patient with Alzheimer's disease showing a positive tau scan. And here's a series of scans on different patients from a healthy control on the left to MCI to mild AD to severe AD, showing that there's some ability to measure the various stages of tau accumulation. So this is the new hot thing in the study of Alzheimer's disease, and we've applied for funding from both the Department of Defense and the NIH to start to do tau scanning in the Alzheimer's disease neuroimaging initiative. The preliminary results with tau PET are very encouraging, but probably only 100 patients worldwide have been studied. And we're going to expect an explosion of new data. And it's possible that looking at the progression of tau could be an outcome measure that would be used in clinical trials, which could potentially accelerate clinical trials. The next slide is a worldwide map of what we call the worldwide ADNI. Our success of the Alzheimer's Disease Neuroimaging Initiative in the United States led to similar studies in Australia, in Europe, in Japan, in Korea, in China, and in South America. So we now have what we call the worldwide ADNI movement. We have a meeting every year, and this has led to a whole group of clinical sites which are all using the same methods and are sharing the data worldwide, which greatly facilitates international clinical trials. So the final thing I want to talk about is this project that we've started here in San Francisco, but we hope is going to have a national or potentially even an international impact, called the Brain Health Registry. So what is the major obstacle to finding effective treatments for Alzheimer's disease? That's a very important question. In my view, the issue is not having enough compounds to study, because there are many, many promising compounds being identified to treat A beta and tau and other things. The chemists and the biologists are developing all kinds of compounds that work on mouse models and other kinds of cell biology models. The problem is that the cost of doing human trials is what is rate limiting. It's so expensive to do a human study that it's not possible to do too many of these studies. Each company can only do 1 or 2 studies at most at a time. And there's only maybe 6 or 8 large companies that have the resources to do it. So we're very, very limited by the ability to do the human studies. The human studies are so expensive. So-called phase 3 human studies cost over $100 million apiece. So the question is, what can we do to speed up the human studies so we can get to a cure faster? And how can we reduce the cost? That's the question I keep asking myself. And it turns out that one major cost in doing human studies is simply finding people who are suitable for a trial. Just getting the people. It's just not so easy. You would think Alzheimer's is so common, why can't we just find people who can do it? But not everybody wants to be in the trial. People have exclusions. You could see from the slide I showed you about the Department of Defense study, we mailed out 9,000 brochures. We got 58 people. It's a lot of work. You have to go through a lot of screening. So what is the solution to that? Or what is an approach to that? One possibility is to establish what I call a cohort, established cohorts of trial-ready people. People who are signed up and willing to participate in the trial out of the goodness of their heart, and they think it'll be interesting. So that led to starting the Brain Health Registry. It's simply a website. It's a quite inexpensive thing to do, and it's an inexpensive thing that can grow because it can scale. And we've been working on it for a couple of years, and we only launched it a couple of months ago. It's an internet-based registry for the recruitment, assessment, and longitudinal monitoring for clinical neuroscience research. And I'm hoping you're writing this down, because I'm asking each of you to sign up and then get your family and your friends and everybody you know and everybody on your Facebook, sign up on the Brain Health Registry. And I'm going to spend another couple of minutes explaining to you about this registry, why we're doing it this way. And then I really would like your feedback. If you go to the registry, there's a contact us, there's an email, or you can email me directly, because we're very interested in we're trying to understand how to make this work and how to make it simple, safe, easy, private, doesn't cost a thing. Okay? It's free. The goal is to reduce the cost of Alzheimer's clinical trials. That's why we're doing it. It's an online registry for recruitment, screening, and monitoring progression. It's available to any investigator who wants to use it. So if a scientist in San Francisco or a scientist in New York wants to use this registry, they would contact us, and we will work with them to help them get subjects. That's the point of the study. If a company is doing a clinical trial and they want us to help them find subjects for their trial, that's what it's all about. Of course, it's all approved by our institutional review board. It's all done under the University of California, San Francisco. Nonprofit. Privacy is completely protected. Don't be concerned about that. And also, there's always informed consent at every step of the way. So if people want to sign up, they can sign up. And then if we contact you or your parents or your grandparents or your friends about being in a study, if you don't want to be in a study, you say, I don't want to be in the study. Okay. So the goal is to establish a large cohort of elders who would be monitored longitudinally. Specifically, in the Bay Area, I'd like to get 50,000 people over the age of 65, healthy people or people with a little mild problem, who will just be sign up and then will regularly come back to the website and answer our questions and take our tests. We want to develop online tests to indicate elders who are at risk for Alzheimer's disease. That's the key, to find a way to get people to find out who's at risk. Because there's no sense to treating somebody who's got no risk. You only want to treat people who are probably at high risk. And there are some things that we know increase your risk. Your age, whether you got it in your family, whether or not you have the gene, or whether you have amyloid in the brain. Those are the major risk factors. But Finding out if you have amyloid in the brain requires a PET scan that costs many thousands of dollars. You just can't do that widely on a large number of people. But another risk is whether or not your cognition is declining. Your ability to think, your ability to remember, if that begins to decline, that's a very powerful risk factor. And one big problem in the Alzheimer's field is that when you begin with high-functioning people, let's say somebody who's got an IQ of 120, that person is going to decline a lot before they become abnormal. They've got a long way to go before their cognitive functioning actually gets below the normal level because they're beginning at such a high functioning rate. But when a patient comes to a clinic, it's hard to know where they were 3 years ago. So what we did in this study is we've developed ways to monitor cognition. But there are problems with doing an online study like this. I want to say it's not easy to do this. There's concerns about privacy, reliability, validity, generalizability, and feasibility, whether or not it really can be done. That's the whole purpose of this study, is to see whether we can do it and see whether we can get reliable data. So the brainhealthregistry.org is UCSF-based. You sign informed consent. There are questionnaires that you answer on the website about your age, your family history, whether you have a memory problem, whether you have a sleep problem, whether you have a depression problem, whether you have an anxiety problem, about diet, exercise, education, stuff like that. And then we have 2 online neuropsych test batteries. One is from Cogstate, and one is from Lumosity. The Cogstate is a company based in Australia that is really the industry standard. They're a very well-established company that makes computer-based neuropsychological tests. And they've already shown that longitudinal measurements, that is over-time measurements with a Cogstate computer test battery, can help predict whether somebody has amyloid in their brain. In other words, normal healthy people who are declining, still normal but are declining, have a much higher incidence of amyloid in their brain than normal healthy people who are not declining. Makes sense. Lumosity is a San Francisco-based company. Almost most of you probably have heard of Lumosity because they advertise so much. It's a very successful company that sells online computer games which they claim will improve your brain functioning. They have right now 70 million people signed up on their website. It's unbelievable. In addition to their games, they have cognitive tests called the brain performance test. And they've already done some data showing age effects and so forth. So we started working with Lumosity in a number of ways, which I'll explain to you. But before I get to some more details, why should we create another registry? There are other registries. There's the Alzheimer's Prevention Initiative. You may have heard of that. That's a good website also to sign up on. And there are Patients Like Me is a for-profit registry for clinical trials. There are a lot of these growing registries of all types. There's probably going to be a registry for traumatic brain injury or sports injuries. Every disease is getting its own registry. But we decided to make this one a little different, and we think it has its own role. First of all, we're not limiting it to Alzheimer's disease, because we believe that if you start calling it an Alzheimer's disease registry, it's going to turn some people off. And secondly, we believe that the registry could be useful for studying things other than Alzheimer's disease. This registry could be used to study sleep disorders, depression, multiple sclerosis, post-operative cognitive decline, traumatic brain injury. You could use the registry for anything, as long as it's neuroscience related. And we're open to talking to all kinds of neurosciences. We are taking people of all ages. We don't exclude anybody. We have questionnaires, which most of the other registries do not. We have the neuropsychological tests online, which, as far as I know, no other registry has. We're advertised by Lumosity widely, and because they have 70 million people, we're hoping that they're going to send out emails to all 70 million of them, and that will help us gain some millions in our registry. And finally, we're taking the approach, which comes out of the ADNI sharing experience, that we're making our website available to other investigators and that we will share the data as long as there's appropriate protection for the subjects. So this is what the website looks like. I'll go through this kind of quickly. You can see you can help save lives by signing up. It's easy, it's safe, it's free. It's not unique to Alzheimer's, as you can see. You can answer questions and play some games, which are the cognitive tests. An interesting fact 25% of everybody who comes to this website and sees that Join Now button signs up, which is a very, very high rate of registration. So it's quick, it's safe, it's free. There's a few steps. We're only asking at the most for 20 or 25 minutes of your time initially, and then at the most over a period of a year, it might be an hour. Not asking for a lot of your time. So this kind of shows some examples of what you would see. You could see medical history, early history, diet, everyday cognition, family tree, current medications. And as you take these various batteries and tests, you get little check marks so you know what you've done. So this is our growth. So we just launched the website at the beginning of this year, just 3 months ago. And now we have 7,000 people already. We had some good public relations going last month, and you can see there was a big spike in March and April of our growth. And we're now planning our next public relations campaign and starting to do more internet advertising. And I'm here to get you to sign up, so maybe we'll see another bump. Okay? This is the average age. These are the ages of the people who signed up. So about half of the people who sign up for this are over 60. But you can see we're getting some younger people as well, especially we think from the Lumosity advertising, because there's a lot of young people who use the Lumosity site. But also, there's quite a few million people over 60 who are playing games on Lumosity. This shows you the gender distribution. More than half, interestingly, more than half the people who signed up are women. About 30% are men. 11% don't want to answer that question. It's San Francisco. In terms of the family history of Alzheimer's disease, I was a little surprised that only 20% of the people who signed up seem to have a family history of Alzheimer's. So now Cogstate. This is a very, very interesting company. They do tests. All of the tests use playing cards. They were designed for people actually who are illiterate. So they're designed that it doesn't matter how much education you have. Basically, you see a card, you have to react to a card or remember whether or not you saw a card. And then now there's Lumos Labs, who makes the Lumosity website. And they are doing 3 things with us. First of all, they're advertising our registry, which is enormously helpful. Secondly, they're providing us with access to the brain performance test. So when you're in our website, when you, it's actually right at this moment today, it's not working, but hopefully in the next few days it'll be working again. You ultimately get to the Lumosity part. You would take the brain performance test of Lumosity, which is a neuropsychological test. We do not currently provide any results to the subjects, except that Lumosity does provide results, but we don't provide the results for the Cogstate test, and we don't do that for research reasons. And they are giving us longitudinal game data, and I'm going to tell you about the longitudinal game data in a minute. It's very interesting. This is a world map of where the Lumos registrants are. You can see they're scattered, especially in the United States and Europe, but they're really all over the world, and they've just launched versions in other languages, so they're really looking for a worldwide market. So now we're talking about a game. There is a game called Memory Match, which you play on the Lumosity site. Some of you are nodding your heads. Memory Match is not a cognitive test, but it is a game that requires you to remember something. And I was interested in how many people might be playing this game over and over and over and over again as a function of time. And it turns out that millions of people have played this game for more than 2 years. So I asked if they could give us the data on their longitudinal game performance, because the question I was asking is, could we identify people over 60 who might be showing decline in their games as a way of identifying people at risk for Alzheimer's disease? In other words, right now we're starting the Brain Health Registry and we're doing these tests, and in 3 years we'll have longitudinal data on the people who've signed up now and come along for 3 years. But Lumosity has data going back 2 or 3 years on the people who've been playing these games. Is it possible that there are decliners there? Because there might be some people who are over 60 who are maybe feeling having a little, I don't know anybody, and all of my friends are, well, what was the name of that guy, or what movie did we see? It's a very common thing for seniors to have, to notice that the brain isn't functioning as well as it was when we were younger. So maybe people are going to Lumos because they see they've got a problem and maybe some change is being detected. So what we have found, quite remarkably, I don't know how well you can see this, but if you look, we can identify decliners. That's my point. We can identify a large number of decliners in the brain games. And the question is, does declining on the brain games really mean that these people, let's say, have more amyloid in their brain or are at risk for decline? So that's a next step, whether or not we can work it out with this company, that we can get access to the subjects, whether we can send emails to the subjects inviting them to participate in studies. That's where this research is going. But we found that we could design a clinical trial using the Lumosity data, which would have a very small sample size to detect a treatment effect. So it's potentially a very powerful way to speed up doing clinical trials and showing that whether or not treatments would be effective. So if there are any people in the room here who are investigators, who are on the faculty at UC or at Stanford, if they want to use the Brain Health Registry, they can contact me at my email address, and we can provide them data on patients in the Bay Area. Of course, we have to get the consent of the subjects, et cetera. But that's the whole purpose of it, is to provide people access to subjects so they don't have to go hunting for subjects. They've got people who've already signed up who want to participate in research. Well, these are the ways that you can help. We're looking for funding, needless to say. We're looking for companies to work with. But most important, we're trying to get people to sign up. We're looking for normal, healthy people of all ages who will come back to the site and be followed longitudinally. We want healthy, normal people, and then we will try to find people who are declining who could be enrolled into clinical trials. So we think it's a breakthrough project, and everybody can participate. It's easy, it's safe, it's free, it's a difference maker. We think that if we could enroll hundreds of thousands or millions of people into the site, it could really have a revolutionary impact on neuroscience research, because it would speed up enrollment into clinical trials of all types. So in conclusion, biomarkers will play an increasing role in Alzheimer's clinical trials and diagnosis. Amyloid scans are available now, and tau scans are coming, and they're going to have a big impact on clinical trials. Everybody agrees with that. The ADNI project and the Department of Defense ADNI demonstrate the value of biomarkers and pave the way for clinical trials that will use them. The use of the internet is going to facilitate clinical trials. Establishing a large cohort of subjects followed longitudinally will assist in recruitment and reduce costs and improve the statistical power of Alzheimer's trials. And an internet-based approach has great promise to accelerate progress in Alzheimer's disease. Thank you very much. You can say it's caused by one or two proteins. So that's the good news. At least we have good targets, and drugs are being developed to be aimed at those targets. Previously, up until just a few years ago, we defined Alzheimer's disease purely by the symptoms. Just like back in the old days, heart attacks were diagnosed by chest pain. But then, through technology, doctors learned that you could diagnose heart attacks by using EKGs, which are electrical signals, and by certain types of blood tests. So we call those biomarkers, tests that give you information about the biology of the disease. What's happened in all of neurology is that increasingly biomarkers are being used to help us identify the diseases. And nowhere has that happened so remarkably as in Alzheimer's disease, especially because of advances in MRI scanning and PET scanning and the ability to measure amyloid and tau in the fluid which we get from a lumbar puncture. So nowadays, of course, the clinical signs and symptoms of a disorder are important, whether a person has memory problems.
To obtain 31p NMR spectra from the kidneys of living rats. Since 1980, has been at the San Francisco VA Medical Center, UCSF. He is currently director of the Center of Imaging for the Neurodegenerative Disease, a 10,000 square foot building with one research MRI, and he is also professor of radiology, medicine, psychiatry, and neurology. He has published over 500 papers. His grants include studies of Alzheimer's disease, vascular dementia, frontotemporal dementia, Gulf War illness, post-traumatic stress disorder, HIV, and other neurodegenerative diseases. He is the principal investigator of the NIA, who funded $60 million for the Alzheimer's Disease Neuroimaging Initiative. In 2007, he was awarded the Middleton Award for outstanding research in the VA. In 2010, he was awarded the Gold Medal of Paul Sabatier University in Toulouse and the Gold Medal of the City of Toulouse in France. In 2011, he accepted the Ronald and Nancy Reagan Research Award of the Alzheimer's Association on behalf of the ADNI project. He is married with 2 grown children. He lives in Mill Valley, California, and he is also a professional jazz pianist and has recorded 2 CDs called Mike Weiner Trio and Mike Weiner Live in Havana. Let's welcome Dr. Weiner.
So I've been studying Alzheimer's disease for the past 25 years. And my mom, who's, God bless her, is 99 years old, she has quite severe Alzheimer's. She still knows who I am, but she has essentially no memory, and she's kind of very slowly progressing, but otherwise very healthy. Emotional problems, depression, and how progressive that is clinically. That's, of course, the bottom line for the patient and the family. But the ability now to make a specific diagnosis using these biomarkers has essentially revolutionized our field and allowed us to be much more specific about what the cause is in an individual patient and ultimately to tailor the treatment. So I've been particularly interested in biomarkers because I got involved with the development of MRI back in the early 1980s, started using MRI to study Alzheimer's disease in the late 1980s, and then more recently I got interested in seeing how we could use biomarkers to improve clinical trials for Alzheimer's disease. So basically, I'm going to talk about 3 things. First, I'm going to talk about the Alzheimer's Disease Neuroimaging Initiative, otherwise known as ADNI, which is a big project standardizing biomarkers for clinical trials, which shares the data. Then I'm going to talk about how we're using the ADNI project specifically to study traumatic brain injury and post-traumatic stress disorder in veterans. And finally, I'm going to talk to you about a new project which we've started in the Bay, healthy, living in a Alzheimer's care facility, so I can really relate to a lot of what you guys are doing. So basically, I want to talk to you about how I see us getting to having ultimately effective treatments and a prevention. Gil Rabinovich did speak about this a little bit earlier, but I'm going to give you what my approach is and how I'm kind of working on it. And at the end of this talk, I'm going to tell you how you could help. The first is really the big picture, which I'll just repeat, because Alzheimer's disease is characterized by amyloid plaques, which are outside of cells, and tau tangles, which are inside of cells, the loss of nerve cells, memory problems, cognitive decline, leading to dementia. Now, what's really remarkable about Alzheimer's disease, it's a really common disease, and it's essentially probably caused by 2 proteins, amyloid and tau. That's the thing to remember, just amyloid and tau. And that gives us targets. In cancer, in diabetes, in schizophrenia, in fact, there's no other common disease that you can mention in which you